Hey guys, this week I'm going to start recording myself, trying to teach you guys how to do some of this stuff instead of just loading videos from YouTube and other sites. On some of the harder topics, I will still download a site for you to go and watch a video such as YouTube in case what I tell you you don't understand, or maybe it's just not enough. Give me any feedback that you may have on whether you like me doing the videos myself better or if you would rather have the YouTube videos. What we're going to be learning about today is something that a lot of students usually get very confused by, but if you will pay attention to what I tell you in the video and take down some important notes, then I think this will not be as confusing for you as it has been for some in the past. What we're going to be learning about today is something called rational and irrational numbers. We're going to talk first of all about rational numbers. So rational numbers are all numbers that are not non-repeating, non-terminating decimals. Now, in order to understand that definition, you have to understand what we mean by non-repeating and by non-terminating. Non-repeating simply means that the decimals don't repeat a pattern, okay? And non-terminating means that they go on forever or they never end. Because if you terminate something, you end it. So when we say non-terminating, that means we don't end it. So it's going to go on forever. When you're looking at a number on your calculator screen, if you have a decimal and that decimal takes up your entire screen on the calculator, that means that it goes on forever. The reason that it doesn't keep going on your calculator screen is because your screen runs out of room. But if you had a much bigger calculator screen, then you would just keep having numbers keep on going and going and going. So just remember, all numbers that are not non-repeating, non-terminating decimals are rational. Feel free to pause the video whenever you need to if you may be trying to write some of this stuff down or to take notes. Some examples of rational numbers. 8.5. You see how 8.5 is a decimal number, but it doesn't go on forever. It stops. So since it stops, we say that it terminates. So it's rational. 85 tenths. Now, what you have to do if you have a fraction is you have to change it to a decimal. And hopefully you remember that to change a fraction to a decimal, all you have to do is divide it. So if you do 85 divided by 10, you'll get 8.5. So 8.5, of course, we just had, is a terminating decimal, so it's rational. 1/3. When you change 1/3 to a decimal, you get decimal 3333333. Now that repeats a pattern. It's going to be 3 going forever. So since it does repeat, it's rational. 5 is rational because it's not a decimal that goes on forever without repeating. 1.95, I think that's a 9, yes, is a decimal, but it doesn't go on forever. 0.001 doesn't go on forever. Negative 0.1 doesn't go on forever, so it's rational. The 0.111 with the dot, 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 hopefully you know that the dot, dot, dot means that it goes on forever. So since this is a decimal that goes on forever, but it does repeat, we know it repeats because it has the dot, dot, dot after the ones. That's rational since it repeats. Negative 1/10. If you divide that out on your calculator, it's going to give you negative 0.1. Since that decimal stops or terminates, it's rational. 3 divided by 2 gives you 1.5. That's rational. Square root of 25 is 5. Now, if you don't remember how to get the square root of 25, the way you get the square root is you hit the second button and then the X2 key. If you notice above the X2 key, that's where it has what's called the radical or the square root symbol. So hit second X2 25 and it will give you 5. Well, we know 5 is a rational number. Negative 16, it's not even a decimal, so it's rational. If you figure out what the square root of 400 is, it's 20. We know that's rational. 16.79. Now, hopefully you learned in previous grades that whenever you have a bar over a number, it means that that number repeats forever. So 16.79 would be the same as 16.7999999. The 9 repeats. So since a repeating decimal, it's rational. Put the two R's together. Repeats means rational. 2.86444. Now the ... after the 3 fours means that those fours are going to repeat forever and ever. So since it repeats, it's rational. Like I just said, put the R's together. If it repeats, it's rational. Hopefully by seeing some of these examples of rational numbers, it will make more sense to you what a rational number is. Now we're going to talk about irrational numbers. There's only one thing that can be irrational. It says here in your definition, the only kind of number that can be irrational is a non-repeating, which we know means it doesn't repeat, non-terminating, which means it doesn't end or it goes on forever, decimal. So a non-repeating, non-terminating decimal. That is the only thing that is irrational. Every other number is rational. The decimal goes on forever without repeating a pattern. That's what irrational is. That's the only thing irrational is. A decimal. Folks, if it's not a decimal number, then it's rational. Because in order to be irrational, it has to be a decimal, first of all. It has to go on forever. So if it's a decimal number that doesn't go on forever, we know it's rational. It has to go on forever. In other words, it has to take up your whole calculator screen. And it can't repeat a pattern. Remember how I told you earlier, think of the two R's together. If it repeats, it's rational. So if it doesn't repeat and it goes on forever, that's irrational. That's the only thing that's going to be irrational. Some examples of irrational numbers. Remember, the first one is square root of 10. On your calculator, you hit second, the X2 key, and then the 10. And I'm not exactly sure what it is because I don't have it memorized, but you're going to get 3 points, probably 1, and then a bunch of other numbers that are going to take up your whole calculator screen, and it's not going to repeat a pattern. Hopefully you know what that symbol in the middle is. That's the symbol for pi. And in our class, we talked about pi being 3.14, and you may have heard that in other classes before. But we just round it when we say 3.14. If you find the pi key on your calculator and you hit that, then that's going to show you 3.14 and a bunch of other numbers on it. And it's going to go on forever because it's going to take up your whole calculator screen without repeating. So pi is actually an irrational number. 2.876921 ... We know that the ... means it goes on forever. And if you can see, there's no pattern repeated there. So since it does not repeat, it's irrational. Negative 0.010010001 ... This goes on forever because of the 3 dots, but it doesn't repeat the same numbers over and over again. It may look to you like it is, but what it's doing is adding an extra 0 each time, and that's not the same number being repeated. So that's irrational. The square root of 87, I don't know the exact numbers because I don't have them memorized, but it's 9 point something, which is all going to take up your calculator screen and not repeat a pattern. If you're using the online calculator or if you have a calculator, you can put that in and see what it looks like yourself. The next one, the negative 4.823196, the decimals, and it goes on forever and you see no numbers repeat. 1/7, if you divide that out, you'll see it's a decimal that goes on forever. Same thing with negative 2/13. Square root of 43 is going to be 6 point something that will take up your whole screen without a pattern. And then you see the last example goes on forever and doesn't repeat a pattern. So guys, you must remember when you're doing rational and irrational that there is only one kind of number, only one kind of number that is irrational. That's the non-repeating, non-terminating decimal. It doesn't repeat the same numbers and it doesn't end. It will take up your whole calculator screen and the same numbers won't be repeated. That is the only thing that is irrational. All other numbers are going to be rational, okay? All numbers that are not non-repeating, non-terminating decimals. So once again, some of the examples would be 8.5, like the whole number 1. Whenever you have a fraction and you divide it out and it doesn't go on forever, or if like 1/3, when you divide it out, it does go on forever, but it repeats 3, 3, 3, 3, 3. The rational and the repeat go together. So hopefully this will help you know a little bit about the difference between rational and irrational numbers. I will also include another video from YouTube that maybe will help explain it to you better in case this video didn't make sense to you. Hopefully this will help though. Let me know if you have any questions or any concerns or any kind of problems I can help you with. Just send me an email. See you next time.